Hi everybody, welcome back to the Feynman Technique. So today we're going to be evaluating this parameterized Gaussian integral. Now this is not a form that we have done before on this channel. It looks similar to some of the forms that we've done, but not exactly. So let's go. All right. So first of all, let's just remember this fact that the integral from 0 to infinity of this is square root of pi over 2 alpha. We've derived that previously. Okay, so we're going to be using that. All right, now let's differentiate our I of b on both sides with respect to b using the Leibniz rule for differentiation under the integral sign. So the partial with respect to b of our integrand is just this, so we can replace it. So now we have I prime of b is equal to this. All right, great. Now let's just take a little detour here, and let's just consider the derivative with respect to x of our integrand. Okay. Well, the derivative with respect to our integrand is going to give us this. All right. Well, if we integrate from negative infinity to infinity, the on both sides of that equation, we end up with this. And this is very easy to evaluate. This is just the derivative of some function, anti-differentiated, and then evaluated at infinity and negative infinity. And in both cases, it will equal 0. So this side is actually just going to be equal to 0. And we can see that right there. So now 0 is equal to this after we rearrange and perform a little bit of algebra, split the integral, and factor out constants and all that stuff. All right, so now we have this. And you'll note, look at this. This part right here is exactly I prime of b, and this part right here is exactly I of b. So we have 0 is equal to negative 2ai prime plus bi. All right. So we can rearrange that to get this. This is an easily solvable differential equation. All we have to do is integrate both sides with respect to b. And we're going to start calling our I of b just I from now on. Okay. So we have 1 over I di. This is our di right here, basically. So 1 over I di is equal to this. All right, so we integrate both sides, and we end up with natural log of our integral is equal to this plus a constant of integration. All right, if we exponentiate both sides, we end up with this after we absorb e to the c1 into a cleaner constant, just plain old c, capital C. So this is our I of b, but now we need to solve for c. Well, if we plug in b is equal to 0 to I of b, we find that our c has got to be equal to this integral right here. All right, now we should recognize this integral. If we look at our toolkit right here, we can see that that integral is going to evaluate to, well, let's see, the one from 0 to infinity would be square root of pi over 4a. So this one is going to be square root of pi over a, square root of quantity pi over a. All right, let's see. Yeah, let's just do the algebra here. Yep. And yeah, you can pause the video if you want to see all these steps. So we get c is equal to this, and yeah, that's what I thought it was going to be. C is equal to square root of pi over a. Alrighty. And now we're done. So we just substitute c back, square root of pi over a in for c, and we have our final evaluation here. All right, guys, I hope you enjoyed that, and we will see you next time.